This conference will now be recorded.
Good morning, everyone. I welcome you all for fifth day of Faculty Development Program on SAP 2000. So I request all the participants, faculty members, PG research scholars, please inform your friends to join the session immediately, because as today is the last day, we have to finish all the parts. So there is a one-time history analysis left. And today the trainer is going to show you a real-time model which is going to be generated through SAP 2000, right? And trainer is also ready. Okay, yeah, Arun, over to you. We can start the session. Anyway, they will join in between, because we are going to record the video, right? So they can have the session later. Yeah. Okay, Arun, start.
Thank you very much, sir. Good morning, everyone. Welcome to the final day of your MTB section on SAP 2000. So in the first half, for the next 10 to 15 minutes, I'll be taking queries from you guys as the other guys will be joining. Then immediately I'll be starting with the time history analysis, like using the unscaled ground motions, using the scale ground motions. And then after completing the time history analysis, I'll be going to what do we say? A real-time model, like how to generate a model using your AutoCAD files, and how to apply all the loads at different points in your structure, on different beams in your structure, and how to get the concrete design of the structure. So it is for you guys now. If there is any queries or any doubts regarding the previous sections, like if you haven't understood any small part or any concepts in the past two sessions, you can ask me now directly. Can unmute and ask me, or else you can just put them in the chat box and ask me. I'll be waiting for your queries for the next 5 to 10 minutes, and then I'll be starting the session. If you have any queries or doubts, just put it in the chat box, or you can unmute yourself and just ask me. Okay. So how many of you have practiced the previous section, guys? Like how many of you have practiced in the SAP 2000? Like anything? I just want you guys to respond that you are over there. Hello.
So no doubts, guys. See, you can respond. You can ask doubts, and you can get it cleared even based on your MTech projects also. Anything
Yes.
related to analysis, design part, because your trainer won't be available all the time. So okay, this is the right opportunity where you can utilize uh, these sessions to get clarified. I mean, all your doubts related to analysis and design part.
Yes.
Even general questions are also available. I mean, it's open to you guys, because there are only 20 participants. Just 5 minutes we will have an interaction, then we will start the session immediately.
Yes, sir, that's what I was thinking. Just
Yeah.
if we have at least 25 participants, I'll be going to start.
Mm-hmm.
Yes, you can also ask questions regarding your MTech project, like whether what type of project you have to choose, and what will be the, can we design also a steel design in SAP 2000? Yes, we can design a steel design in the SAP 2000, but the only restriction, like only constraint is that you can design the steel sections, Like you can analyze the steel structure and you can select the steel sections and you can check whether those sections are being passed or failed. Like suppose we are designing a telephone tower or a high tension tower or a shed or an industrial shed. All the things which we use in those structures are made up of steel sections, like the purlins, the main trusses, the bracings, the lacings, the rafters, the main cords. All those things we are using the steel structures only. We can analyze this steel structure. The only constraint which you have, which is not, which we cannot do in SAP 2000, is that we cannot model the joints, like the connections. When we are having the plate connections or the welded connections or the riveted connections, we cannot model those kinds of connections in this SAP 2000. Everything else can be done in this SAP 2000. Yes, sir. I practice materials defined slow nodes, assigning analysis. Need to practice pushover thing. Okay, nice. Uday Kiran. That's good, Uday Kiran. And anything regarding your MTech structural engineering thesis work or your MTech projects or your BTech project regarding this softwares, I'm available to answer you guys right now. So you can take this as your advantage and you can ask anything related to the structural engineering. Sir, am I audible clearly, sir?
Yeah, your voice is clear.
Yes, sir. Okay.
23 participants.
So for the joint design, which software we use, we can do that manually, and we will be having some special softwares for steel, especially for steel design, like Tekla. You can do that in Tekla. Yes, Tekla is the one software which you can design that joint, and elemental designs you can do them in ANSYS, Abacus. I think in Midas also it is possible. ANSYS, Abacus, Midas, and Tekla. You can do this you can do the joint designs in ANSYS, Abacus, Tekla, and Midas. All these softwares are available for this joint design, like the elemental designs. Only the joint you can design. You can put the stresses which are on the joint, and you can design the joint if it is passing or failing. We design retrofitting in SAP, sir. This is we design retrofitting in SAP, sir. Retrofitting. No, I think we cannot do this retrofitting in SAP, Sai Shankar. Any other questions? Ask me regarding SAP also. I'll explain what are all the different things which we can do in SAP. And also I'll give you a few topics which are currently running for your MTech thesis. Ask me such kind of questions. I will be answering you those questions. Like what type of project you have to choose, or what are the techniques or things which you have to choose.
Sir, can we do liquefaction factor condition in the build? I mean, for the buildings or any commercial buildings, or that we can do in the SAP? Can we do that?
Soil liquefaction.
Yes, sir.
Yes, you can do the soil properties also in this SAP 2000. There is a options called soil structure interactions part. for SAP-2000. For this, there is a separate menu, and the view are defined. In that you can create links to the four teams or the columns, and you can give this liquefaction and all those properties to the structure.
Okay. Okay, sir. Thank you.
At 11:15, I'll be starting the session, guys. You can ask me anything until then. How many of you are present during the previous class when I was explaining the user-defined hinges for pushover analysis?
Yeah, till now participants are 25. Guys, if you don't mind, can you please switch on your video? So by that I can have a snapshot of these 25 participants. And at last I can have a snapshot of all participants together. Please. I request all, please switch on your cameras. I mean, front video. So by that I can have a snapshot. Everyone. Please, it is very important for us to file the document. Okay, so in that way we need all your presence in terms of video. Please, everyone, just for half a minute, just I will take a snapshot, then you can switch on your videos, no issue. Sai Shankar, Sujit Singh, Sudha, Anuradha Iyer, please, it's my sincere request, because there is a online program where we have to record these videos, and just we need to have all your presence in terms of videos also. Guys, please switch on your videos, because the trainer is going to start the session within 2 minutes, in a couple of minutes. So by that we can close this thing. Tejashwini, you can also. Everyone, yeah, please. Thank you, Sai Shankar. Thank you, Sai Krishna. Vanapati, thank you. And congratulations, Vanapati. He got a job in Ashoka Builders Private Limited. So through this platform, that one of our MTech students got selected in Ashoka Builders Private Limited as a graduate engineer trainee.
Congratulations, guys.
Guys, you can just mute yourself and you can put your video on. That's it. Others, please. Sujit Singh, Sudha, Anuradha Iyer, Harshida ma'am, Mohammed Gupta, Milind Gupta, Anishetty, Kavya, Jayashree ma'am, Tanveer, Vanapati, Sirisha. Please, only 1 minute left for me to, argue to Arun. So we will have a snapshot immediately.
Yes, sir. Let them turn on their cameras, sir.
Yeah, that's what. I don't know why they are feeling shy. Yeah. Please, guys. So only 50% of switched on their videos. Rest of all, you have to.
What a question.
Only.
Okay, my laptop camera is not working. Okay, Mr. No problem.
Okay, fine.
And all the others?
Please, others, Harshida ma'am, Sudha, Sirisha, Jayashree, Sai Kitana, Apurva. Please don't feel shy, guys. This is the way how the online sessions are going to be conducted. So wherever you are, whether you're groomed or not, it's not at all a big deal. You can just switch on for a second and you can switch off. Okay.
Someone were turning off their cameras, turning on and turning off is happening.
Okay, right, Arun. You can start the session. At last, we will have the same kind of thing. Okay.
Yes, sir, definitely. Okay, guys, you can turn off your cameras now. Let me start the session. Today's session. In today's session, we are going to discuss regarding
If you
in today's session, we are going to discuss regarding the time history analysis. There are two different time history analysis which I'm going to explain. The first one will be using the unscaled ground motions, like directly using the accelegrams which we download from the internet or any other sites, or the default accelegrams which are provided by the software. And the second one is by using the scaled accelegrams, like we are changing the intensity of the ground motion. Like suppose a ground motion, you guys are familiar with the ground motion, right? What exactly is the ground motion, guys? I need this session to be an interactive section, so please put your answers in the chat box if you know the answer, or else respond that you don't know the answer. I just wanted this session to be an interactive section. So my question is, what exactly is a ground motion, or what exactly is an accelerogram? Before going to time history analysis, I'm asking you a question. What is an ground motion, or what is an accelerogram? Guys, if you don't know, also no problem. Just put that you don't know the answer. It's okay. Nothing to worry. I'll be explaining you. Don't know, sir. Very nice. Okay. So what is an accelerogram is? It is a plot. It is a plot. It is related to any ground settlement? No, it is not related to ground settlement. A ground motion is nothing but a plot which represents the time on its x-axis and the displacement or the acceleration on the y-axis. You guys are all from the Telangana, Telugu talking state, right? If I speak in Telugu, it is okay, right?
Okay.
Okay. So whenever we see this ECG, ఏదన్నా హాస్పిటల్కి వెళ్ళినప్పుడు మనం ఒక ఈసీజీ తీపించుకుంటే మన హార్ట్ రేట్ అనేది ఒక చిన్న లైన్ లో ఇట్లా అప్ అండ్ డౌన్ ఇట్ విల్ బి ఫ్లక్చువేటింగ్, రైట్? Similar type of thing which is also happen when a earthquake happens. Similar type of thing happens. We will provide different sensors, accelegrams. The sensors are called as accelegrams. వీటిని మనం ఒక స్పెసిఫైడ్ రీజియన్ లో మనం ప్లేస్ చేస్తూ ఉంటాం. లైక్ సపోజ్ ఒక హైదరాబాద్ ఉందనుకోండి, హైదరాబాద్ సరౌండింగ్ ప్లేసెస్ లైక్ సూర్యాపేట్, నల్గొండ, కరీంనగర్, ఆదిలాబాద్, ఇలాంటి ఒక సర్కిల్లో మనం ర్యాండమ్లీ ఇలాంటి సెన్సార్స్ ని ప్లేస్ చేస్తూ ఉంటాం. సో అప్పుడు ఏమవుతుందంటే whenever any earthquake or ground motion happens, this sensors will record the movement of the earth. This sensors will record the movement of the earth. Whenever an earthquake happens, this earthquake emits the energy as earthquake waves. There will be primary waves, secondary waves, P waves, second S waves. These types of waves the earthquake will emit. Based on these waves, మనం ఏవైతే సెన్సార్స్ ప్లేస్ చేసామో ఆ సెన్సార్స్ ఈ ఎర్త్క్విక్ వేవ్స్ ఎలా రెస్పాండ్ అవుతున్నాయి, లైక్ వాట్ ఆర్ ద డిస్ప్లేస్మెంట్స్ ఆఫ్ ద గ్రౌండ్, ఇవన్నీ మెషర్ చేస్తూ ఉంటాయి. దిస్ ఇస్ కాల్డ్ అన్ యాక్సిలోగ్రామ్, రైట్ గైస్? the instrument which is recording this thing is called accelerogram. We'll be also having this at the meteorological department, which is located at Begumpet, and some other sites. They will pick up few sites and they will place this instrument at different locations. So why I am telling about this thing is those are the main source where we get this accelerogram. మనకి ఏదైతే డేటా మన అనాలిసిస్ కి కావాల్సి ఉందో ఆ డేటా మొత్తం మనం ఈ యాక్సిలోగ్రామ్ సైట్స్ నుంచే దొరుకుతుంది. ఈ యాక్సిలోగ్రామ్ సైట్స్ నుంచే విల్ రిసీవ్ ఆల్ ద డేటా లైక్ ద గ్రౌండ్ మోషన్స్ ఆర్ the intensity of the earthquake or the direction of the earthquake. All those data will be getting from this accelegrams itself. Okay, so I think you are clear with this accelegram, what an accelegram is and from where we are getting this accelegram, right? Okay, now before going to our SAP, I'm going to share my screen and I will be showing you few accelegrams. Are you guys able to see my screen? Just respond yes if you see my screen.
Sir. Yes, sir.
Okay. So these are the different accelegrams. The most studied accelegram is Bhuj earthquake, which has happened in Gujarat, Kutch district. It is the most devastating earthquake. Whenever you download an accelegram from any site, you will be having this type of file. Okay, text file untadi. Dantlo it will represent the name of the earthquake, when it has happened, at what time it has happened, and what is the magnitude of the earthquake. Whenever we talk about the magnitude, this will be a richer scale lo measure chestaru, కొన్ని different types of scales lo measure chestaru. Dantlo 7.0 MP is the magnitude, 7.6 MS is the magnitude of the Bhuj earthquake, and the location of the
Matter
different disturbance.
Sir,
Yes.
sir, I have a doubt.
Chapandi.
Sir, this earthquake data is available in PDF format or else in the Word format, I mean in the text document. Previously, I have worked out to do the earthquake and this one earthquake analysis for non-linear analysis. So for that, I have downloaded the PDF file, which it does not work out for me. That's why it will be available in Word format or else PDF format.
So whenever you download this earthquake ground motion data, it may be available in many formats. Like it might be available in PDF formats. అంటే ఆ సైట్ ఏదైతే ఉందో అది ఆ సైట్ మీకు ఎక్సెల్ ఫార్మాట్ లో డౌన్లోడ్ చేయడానికి ఆప్షన్స్ ఉంటాయి, PDF లో డౌన్లోడ్ చేయడానికి ఆప్షన్స్ ఉంటాయి, ఆర్ ఎల్స్ టెక్స్ట్ ఫార్మాట్ లో డౌన్లోడ్ చేయడానికి ఆప్షన్స్ ఉంటాయి. మీరు ఫైనలీ ఏం చేయాలంటే ఏ ఫార్మాట్ అయినా డౌన్లోడ్ చేసినా మీరు టెక్స్ట్ ఫార్మాట్ కి తీసుకొచ్చేయాలి.
ఓకే,
ఏ ఫార్మాట్ అయినా డౌన్లోడ్ చేసినా, యూ కెన్ అండర్స్టాండ్ తెలుగు రైట్?
యా.
ఓకే, సో ఏ ఫార్మాట్ అయినా డౌన్లోడ్ చేసినా మీరు ఇలాంటి టెక్స్ట్ ఫార్మాట్ లోకి మీరు డౌన్లోడ్ చేసుకోవాలి, అంటే కన్వర్ట్ చేసుకోవాలి. PDF డౌన్లోడ్ చేసిన PDF లోపల అన్ని ఉన్న యాక్సిలోగ్రామ్ పాయింట్స్ అన్ని ఈ టెక్స్ట్ డాక్యుమెంట్ లో కాపీ చేసేసుకుని పెట్టుకోవాలి. అండ్ వన్ మోర్ థింగ్ విచ్ యూ హ్యావ్ టు రిమెంబర్ ఇస్ వాట్ ఈస్ ద టైమ్ పీరియడ్ ఆర్ ద టైమ్ ఇంటర్వెల్ ఆఫ్ దట్ యాక్సిలోగ్రామ్. యూ హ్యావ్ టు రిమెంబర్ ద టైమ్ యాక్సిలోగ్రామ్, టైమ్ సెకండ్ ఆర్ ద టైమ్ ఇంటర్వెల్ ఆఫ్ దట్ యాక్సిలోగ్రామ్. పాయింట్స్ ఉన్నాయి, దీని టైం డిఫరెన్స్ ఎంత, ప్రతి ఒక్క పాయింట్ మధ్యలో ఎంత డిఫరెన్స్ ఉంది అది నోట్ చేసుకుంటూ ఉండాలి. ఫర్ దిస్ Bhuj earthquake, the point difference is 0.05 seconds. Okay.
ఓకే సార్. సార్, ఐ హ్యావ్ వన్ మోర్ డౌట్. అంటే మనం ఇప్పుడు బుజ్జి మన ఇండియాలో కాబట్టి బుజ్జి ఒకటే ఉంది. ఇన్ కేస్ ఆఫ్ వరల్డ్ అయితే కనుక మనం బుజ్జి తీసుకోవాలా, అంటే ఇంకేమైనా వేరే క్విక్ డేటా అవైలబుల్ ఉంటుందా?
You will be having data all around the world. I'll explain this. Like in India, we have few earthquakes which are major earthquakes, like the Bhuj earthquake, Koina earthquake, Latur, Sikkim, మనకు మోస్ట్లీ మన బాటమ్ సదర్న్ రీజియన్స్ లో అయితే ఎర్త్క్విక్స్ ఎక్కువ ఫ్రీక్వెన్సీతో అవ్వవు. ఏదైతే నార్థన్
అవును.
రీజియన్ అక్కడే మనకు ఎర్త్క్విక్స్ అనేవి ఎక్కువ ఇంటెన్సిటీ ఆర్ ఎక్కువ ఫ్రీక్వెంట్ గా అయితే ఉంటాయి. అయితే మనం ఇండియాలో ఏదైతే మోడల్ జనరేట్ చేస్తున్నామో, ఇండియాలో రెసిడెన్షియల్ బిల్డింగ్, ఇండియాలో ఎక్కడైతే మోడల్ జనరేట్ చేస్తున్నామో దానికి మనం ఇండియన్ ఎర్త్క్విక్స్ యూజ్ చేసుకోవచ్చు.
Okay.
చేసుకోవచ్చు. ఎందుకంటే ప్రతి ఒక్క ప్లేస్ కి దెర్ ఆర్ డిఫరెంట్ టెక్టానిక్ రీజియన్స్. Like
Yes, sir.
our India is in one tectonic plate. Our Indian continent is one subcontinent is in one tectonic plate. The Eurasian plate, like the North American plate, the South American plate, the Pacific plate, ring of fire అంటారు అక్కడ మనం ఏదైతే ఉంటుందో అట్లా డిఫరెంట్
Okay.
టెక్టానిక్ ప్లేట్స్ ఉంటాయి. సో ఫర్ ఈచ్ రీజన్ ఇఫ్ యూ సెలెక్ట్ ద లోకల్ ఎర్త్క్విక్స్ ఇట్ విల్ బి బెటర్.
Okay. It is better to be select the local earthquake data.
Yes, exactly. So I'll be showing you one thing. All the earthquakes in India. Like I have done a few things.
Arun, if you don't mind, actually, we'll continue the session. We'll put all the queries at last. So
Okay,
by that,
definitely.
Okay, sir.
yeah, and finish
Okay,
the
definitely.
contents, in a clear.
Yes, sir. There is this.
I request participants, so please have your questionnaire, and we will have a discussion at last, part of the session. Okay, at least for 15 to 20 minutes. Okay.
Okay, sir. Okay. So whenever you're getting any doubts, just note them down in a paper or anything. At the end of the session, we'll be dealing with this. Okay. So now, like the final earthquake data, Excels. These are the different earthquakes which are happened in India. Bhuj earthquake, Chamba earthquake, Chamoli earthquake, India, Bangladesh, India, Nepal, Koina earthquake, Nepal, Gokra, Sikkim, Uttarakshi, Dharmashala, okay, Uttarakshi, Dharmashala, Chamoli. Like that, we'll be having some major earthquakes which are happened in India. You can use the data for your time history analysis, or else you can use some other data such as El Centro. El Centro is the most commonly known data. El Centro, Oak Valley, and all these things. If you get an Excel file, if you download an Excel file, what you have to do is it will be representing the time and the displacement and the acceleration value. The time gap is 0.02 seconds, and this is the acceleration value. You have to copy this acceleration value. ఈ యాక్సలరేషన్ వాల్యూ ఏదైతే ఉందో ఇది కాపీ చేసేసుకుని మీరు డైరెక్ట్ ఒక టెక్స్ట్ ఫైల్లోకి కాపీ చేసుకోవాలి. టెక్స్ట్ ఫైల్లో కాపీ చేసేసుకుంటే ఇట్ విల్ బి సంథింగ్ లైక్ దిస్. It will be something like this. You have to put it in the form of a text file. Okay, so this is basic how to get the text files for your time history analysis, how to get your accelegrams. You can download them from different sites which are available on the internet. I'll be showing them. I'll be giving the links for those sites in the WhatsApp group. So okay, let's get back to our SAP-2000, and let's start with our model, like how to create this time history analysis and how to analyze them. New model. This new model, select the 3 frame. I'm just putting them all to the default values. You can model anything and use the same procedure. Like the modeling, if I do the modeling again and again, it will be taking much time. So I'm just putting them to the default values. Click OK. And now what I'm doing is I'm changing the restraints. Fixed restraint. Okay. Then You can assign those properties directly to the selection. Like you can select few beams and change the property of the beams directly just by select parallel lines. I selected this parallel lines, and again I am selecting the other parallel lines. Okay, now click on assign frame section properties. I'm assigning the B1 section to the all the beams. Apply. Okay, now if you see, the B1 properties has been assigned to the beams. And next I want to change this fsec1 to column C1. So for that, what I'm doing is I'm just clicking on the select parallel lines, select straight line objects, and then I'm selecting the columns and assign frame sections and C1. Click on apply. Okay, now your B1 and C1 has been created. If you want to see them in an extruded view, if you now these are showing in the form of an wire type of view. If you want to see them in an extruded view, just click on this option, and in the general option, this one is the option, this tick mark, the small tick mark type of option. In this in the general option, you have to click on extrude and click on apply. Okay, you have to click on extrude and apply. All your elements will be extruded. Now if you see this orientation of this column is along the x direction. Now I don't want the orientation of this column to be in x direction, and I want to change its orientation. For such type of issues, what you have to do is select the columns, select those columns, and then click on assign. In this assign, you will be having the frame option. In this frame, you will be having the local axis. Okay, the assign in the frame, you will be having the local axis, and then change its angle from 0 to 90 degrees and click apply. Okay, now the orientation has been changed. Okay, in this way you can change the orientation of any member, like even it is a beam, or even it is a column, or even it is a secondary beam. You can change the orientation of those materials or those elements. Now let us go to the next part. I'm changing this to the original view, like the standard view. Apply. Okay, in order to make this local access display, you have to click on assign and click on clear display of assigns. Now it will be cleaner. Then after that, I am going to click on define. I'm creating few load patterns, like the dead load and the live load. Live load, add new load pattern, click OK. Now after that, let's assign those loads. Select properties. Am I rushing up, guys? Are you able to follow me, or should I slow down a little bit? No, sir. Okay, fine. What I was frame sections. In this frame sections, select the B1 and click on select. All your frame sections will be selected, and then click on assign frame loads distributed. And this for the dead load, I am giving it as 12.5, and add to existing loads. Apply. Okay, now select the sections again. Now change the load type to live. I'm just changing it to 2 kilonewtons. Apply. Okay, now 2 kilonewtons node has been added. Now let us go for our time history load cases and all those things. From here, I'll be first I will be explaining you how to do this time history with unscaled ground motions, or the raw ground motions which we download from the internet. Further, click on define. In this define, first you have to create a time history function. I repeat again, in the define, you have to click on function. In this function, you have to click on time history function. Okay. After selecting this, you'll be getting a pop-up box, define time history functions. In this, choose the type of function to add. In this, you can add from file. You have to select from file. I repeat this once again. Define functions, time history. In this drop down, you have to select from file. Okay. After selecting from file, you have to click on add new function. And this add new function. Now let us give Budge earthquake. Let us select the Budge earthquake. Budge earthquake, and then you have to browse for the file where it is located at. The file should be text file, guys. The file should be text file, which means the extension of the file should be .txt. Click on browse. Okay, this someone were asking me where to save the, what do we say, license. You have to save the license in this CSI license and this this folder, this complete folder. So let's go back to our desktop. In the ground motion data, the Burj earthquake. Okay, right on the right side of the ground motion data, on the name itself, it is represented 0.005. It is the time interval of your Burj earthquake. Okay, I'm selecting this Burj earthquake and I'm clicking on open. Okay, if you see over here, it will be representing some line like this. You have to change this. Like how to change this is, you have to click this on 0.005 and then number of header lines to skip. You have to check the file, view file. Okay, you have to skip this 4 lines. You have to skip this 4 lines. Number of header lines to skip is 4, 0. Zero 0.005 seconds. You have to put the value of this to 0.005. Okay. Okay, right. So if you move your cursor over this, you will be displayed with the displacement and the time seconds. Now if you put it at the end, the time seconds is one time period is 154 seconds. The total Burj earthquake happened for around 154 seconds, or 154 seconds. And then what you have to do is you have to click on OK to save this file. Click on OK to save this function. To save this function. Okay. Now your function has been saved. Okay, your function has been saved. I repeat this process once again. I repeat this saving of the function once again. You have to click on close. Now it has been not saved, so click on define functions, time history. In this, you have to click on from file, add new function, give the function a name, and then click for browse. I'm selecting the Burj file, Burj 0.005, open. And then 0.005, and header lines to skip is 4, and the number of points per line is 1. Click on display graph. Your earthquake data has been imported to this SAP-2000. This is the earthquake accelerogram, and click OK. And then click OK to save this Budge function which you have just created. Okay. After that, what you have to do is you have to go to define. In this define, you have to go for load cases. On this load cases, you have to create a new load case called time history function. The new load case is a time history function. BHUJ. Okay. This is the FNA, fast nonlinear analysis. Whenever you use this FNA, the analysis will happen much faster than all the other types of analysis over here. And then you have to set the loads applied, acceleration in the direction of U1. U1 is nothing but the earthquake is coming in the direction of x-axis. The function is Budge, and the scale factor. This is the important thing which you have to change over here. The scale factor. In order to measure the scale factor, there is a small formula. The formula is Ig by R. Okay. So what are all these terms are? Nothing but I is your importance factor of the building. You will be getting this importance factor of the building in IS 1893 2016. If it is a building which has residents less than 200, it is considered as a normal building, and if it is having more than 200, it will be defined as an important building. And for an important building, the value will be 1.5. For a normal building, the value will be 1. And for assembly building, for educational institutional buildings, for government buildings, all those buildings are considered as important buildings, and its value will be 1.5. The I value will be 1.5 for those buildings. And coming to G, G is nothing but your acceleration due to gravity. The value of G would be 9.8 meter per second. 9.8 meter per second square, and I will be 1. I will be 1. The importance factor is 1, and G will be 9.8 meter per second, and R will be your response reduction factor. I repeat this once again. R will be your response reduction factor. You will be getting this value from IS 1893. IS 1893 for earthquake engineering, earthquake loads, and all those earthquake 1893. In that, you will be getting the value of this R. For general concrete structures, the value of R will be 5. Let's check this once. I'll be just opening. This is the code book, IS 1893 Part 1, 2016. Okay. Okay. This one is the factor. Important factor is given IS 1893 Part 1 for corresponding section structures when not specified. The minimum values of I shall be 1.5 for critical and lifeline structures like important buildings, 1.2 for business continuity structures, and 1.0 for rest. Let's see what all this 1.5, 1.2, and 1.0. And the R value, R is nothing but your response reduction factor given in IS 1893 Part 1 to 5 for corresponding structure. Which one is table 8 important factor. Important services for community buildings, for example, critical government buildings, emergency buildings, for all those types of structures, the I value will be 1.5. For residential buildings or commercial buildings, those listed with occupancy more than 200%, it will be 1.2. All other buildings, it is 1.0. So there is this one is the I value, and we have one other value to define, which is R, response reduction factor. In the table 9 it will be displayed. Let's search for the table 9. Okay, this one is the response reduction factor. Response reduction factor R for our building systems, R value for moment frame. And this, which frame we are going to consider is RC building with special moment resisting frame is our building. Whenever we are modeling, we'll be considering RC frame with special moment resisting frame, SMRF. The response reduction of our building, the value of R for our building is 5.0. 5.0. Okay, so just note down these values, guys. I value is 1.0, R value is 5.0, and G value is 9.8 meter per second square. Okay, getting back to our SAP again. Here you have to mention the scale factor. The formula for your scale factor is S equal to IG by R, which means 1.0 into 1.0 into 9.8 divided by 5.0, which would be, I need you guys to answer in the chat box, 1.98 exactly. So 1.0 into 9.8 divided by 5.0, it will be 1.96. So the scale factor is 1.96, and click on add, and click on add. The next thing, after defining this one, the next thing which you have to define is number of output time steps. Number of output time steps. This will be the number of accelerogram points which are available in your file which you have selected. This is the number of output time steps is nothing but the number of time steps, like the number of accelerogram points which are in your file. Burj earthquake, Okay. This is the 26706. 26706 is the number of accelerogram points. Let's confirm this once again. 26706. Okay, we have to delete this first three. We have to subtract the first three. Shift Control down. 26723 minus 3 would be 26720. 26720. Just now note down this value too. Okay, we just this is the correct value. 26706. Like there are zeros at the end. We should not consider those zeros. So this will be the correct value. 26706. Two six seven zero six. Right, guys? 26706. Yes. Okay. So now the step size. We have to define the step size. The step size is nothing but the time interval between two steps. It will be 0.005, right? And after defining these two things, you just have to make this default. If you are introducing any type of damping into the structure, you have to change these properties. And after that, if you do not get any outputs, you have to change this properties. Click OK, and that's it, guys. Your time history load hills has been created. And then click OK, and then click OK. Click on Analyze. Click on Run Analysis. Click on Run now. Okay. Now let's see if your analysis is done perfectly or if there are any errors. Like for that, what you have to do is click on Display. Sorry, click on Assign. Clear Display of Assign. Select one node. Select any one of the node. This node 15. I'm selecting this node. I'm selecting this node. This one is node 24. Node 24 or any other. I'm just selecting this node for taking the outputs, like the displacements of this node. I'm selecting the node 15 now. participant features, total number of steps, then your time history has been completed, and then click on display. Show plot functions. The load case which you have to select is the time history function which you have created over here, and then you have to define the plot function. The horizontal function will be time always. If you want to change, you can change, but always the horizontal function in time history, it would be time only. The next one, define plot function. On this, add joint displacement forces. I repeat this once again. In the define plot function, you have to click on add load function and you have to select joint displacement forces. Okay, add plot function, and you will be displayed with joint ID. You have to give the joint ID, joint 15. I want the acceleration of this joint 15 in the direction of ux. As we have applied our ground motion in the direction of ux, I want the acceleration in ux, and click OK. And joint 15 has been created, and click OK. Joint 15 and add it to the vertical function and click on display. Okay. This is the displacement of your joint 15 for the given accelerogram. Previously, we have defined the accelerogram. We have created a Budge earthquake accelerogram, and we have applied it towards the direction of the x to our model. When the model is subjected to that earthquake, the joint 15 in the building is having the acceleration or the displacement in this form. At first 0 seconds it is nothing. At the 40 or 50, 45, at between 45 or 60, it is getting the highest acceleration. Okay, everyone understood this, right? Like how to take the output of your time history function. Okay, I'll be explaining this once again. Budge accelerogram. Done. So there is one other thing which you can do is click on display, click on show deformed shapes, select the Budge earthquake, absolute acceleration, the time seconds. 0 is the time second. Click on apply. For 0 seconds, see how your structure has been deformed at 0 seconds. Now let's go for some 45 seconds. 45 seconds. Click apply. Your structure has moved from here to here. Like all the structure, the deformation is happening more at 45 seconds. Again, let's go for some more. 60. Apply. And again, your structure is moving. In this way, you can select the point at which your structure behavior is for a given ground motion. Like for a given ground motion at a point of time, like consider the earthquake is happening for around 60 to 120 seconds. Generally all the earthquakes will be less than 30 seconds, but the Budge earthquake is happening, it happened for larger time period. That's why the devastation of Budge earthquake was larger. So in that time span, in that time period or the interval of the time, if you want to select a specific second, and if you want to see the output of your structure, you have to enter the value of the time over here. Now I'm entering some 55 and click on and what the output you want to see, the absolute acceleration or the relative acceleration or the relative displacement. If you activate this wire shadow, it will show the original shape, original place, and the displaced shape. Okay, see this one is your original shape. You guys are able to follow, right? This gray area is your original building, like before application of the load. And then after applying the ground motion at 55 seconds, your building will be displayed at this distance from its original shape. original location. Okay, is there any doubt regarding this, guys? Hello, it is clear for you, right, until now, like how to create the time history case and time history function and the time history case? Just respond in your chat boxes, guys. If you do not understand, I'm ready to explain you once again, guys. I'm waiting for your responses. So no one are responding. I think everyone have understood this part. So I'm moving forward to the next part. Okay. So this is how you will be doing the time history analysis using an unscaled ground motion. And in this, you can also check the forces, like the maximum forces which are happening in your structure for your Burj earthquake. The maximum moments, it will take a little bit of time to display this thing. Maximum moments, these are the maximum moments. Only the columns are failing in the x direction. See over here, guys, only the maximum moments are generating in the columns. So whenever an earthquake happens, the maximum stress or the displacements or the moments, those will be generated in the columns only. Right. Shear forces, shear in two direction, apply. Maximum shear in the, what do I say, columns itself. In the columns, the maximum shears. Okay. Axial forces developed due to the Burj earthquake, the maximum axial forces. In the columns, again in the columns. So the things which you have to remember is whenever you are modeling a structure, these things like the columns should be able to withstand a larger amount of moments or a larger amount of stresses whenever an earthquake scenario occurs. Like how I have given this Burj earthquake and all the columns are showing the maximum outputs, right? So the column should be designed in such a way that all these moments or the shear forces should be uh, accepted. Like it should not fail. The column should not fail when this type of moments or shear forces occur. Okay. So by this, I'm ending the first concept, use time history using the unscaled ground motion. Okay. Everyone are clear with the unscaled ground motion, right? Should I explain this process once again fastly? I need your responses, guys. Okay. You want me to explain once again? Once more explain. Okay, fine. I'll be going in fast forward. Like I'll be explaining you this once again. In order now you have to unlock this one. Unlock. Okay. In order to create a time history function or in order to do a time history analysis, the first thing which you have to do is you have to click on define and you have to click on this functions. In this functions, you have to click on time history function, and then you have to create a new function using the from file option in the drop down. Okay, in the from file option, you have to click on add new function. You have to give it as a name. You have to give it a name. You have to browse for the file which it has been located. Okay, this is the Koina earthquake. You have to give the how many seconds it is. You have to give the time interval values. For Koina earthquakes, the time interval is 0.02 seconds. So the total earthquake was 19 seconds. After defining this time history function, click OK. Again, click OK. Now you have to define the time history load case. First, we have defined the time history function. Now you have to define the time history load case. In this, click on the load case. Click on add new load case. In this add new load case, you have to give the name Koina earthquake, and then you have to set the function as time history. Set the load case type as time history, and then I'm just changing this to from linear to non-linear. It is fast non-linear analysis. Fast non-linear analysis. You can also change to this direct integration, but it will take much time to solve the solve the background equations of your time history analysis. So for your better, faster analysis, you can select this model, and then in this you have to in this load supplied you have to change it to acceleration. You have to go for the load in application direction of your ground motion. U1 is the x direction, U2 is the y direction. Now I'm just giving it in the U1 direction, and the function I'm giving it as Koina, and the scale factor. What is the answer which we have got before for the scale factor? That Ig by R. Can anyone put it in the chat box? What is the scale factor which we have got for 1.96? So it will be 1.96, and click on add. And then after that, what you have to do is you have to define the number of output time steps. For defining the output time steps, you have to know the number of points which are in the accelerogram. And going back to the accelerogram once again. There is Koina. So the number of points is 1001. 1001 points are there in this Koina earthquake. Have to get back to your SAP again, and then from here I just putting 1, and then you have to give this as 0.02 seconds. 0.02 seconds is the time step of each accelerogram. The difference between the first accelerogram and the second point in the accelerogram is 0.02 seconds. And then if you have any model damping properties, you can change these properties and click OK, and your new time history class is created, and click OK again, and then click on analyze, click on set load cases to run, and run all the load cases. Depending on your model, and depending on the different type of materials and geometry in your model, and depending on the load cases, like it is a non-linear analysis or a linear analysis or a time history analysis, different types of timings, the like a different time of time period will be taken for analysis. Sometimes it will be the analysis will be completed faster, sometimes it will take few hours, and in some cases which I have seen, it will take almost a whole night and almost 2-3 days to complete the analysis, depending on the structure. So now, as it is a small structure, the analysis has been completed. In this, after completion, click on display. In order to get the outputs of your time history analysis, first you have to select a joint. You can either define a diaphragm and select the diaphragm, or else you can select any point in your building, in your model, and get its joint ID. If you double click on this, display sign, clear display of assigns. The label is 24. The joint label is 24. If you click on display, in this, you'll be having an option called show plot functions. Show plot functions, all the hysteresis curves, all the time history curves, these types of curves will be obtained from this plot functions. Show plot functions. And then previously I have defined the joint 15 function, right? I'm creating this function once again. I'm creating a function once again. Define plot functions, add a joint displacement force function, add plot function, and the joint ID I'm giving it as 15, and I need the displacement, or I need the displacement of the joint for the earthquake ground motion which I have given. Displacement of the joint for the earthquake ground motion which I have given in the direction of X. In the direction of X, and then click OK. Here another joint will be, plot function will be created. Click OK, and then joint 15.1, click add. It will be added into the vertical function, and click on display. Okay, this is the displacement of the joint for the given earthquake. This is for the Burj earthquake. Now if you want for the Koina earthquake, select the Koina earthquake and click display. This is for the Koina earthquake output. Okay, this is clear for everyone right now. Okay, I'm just clicking OK. And again, if you want to have different type of graphs over imposed on one another, you can add like this and click on display. So if you see, the both are green lines. Wait a minute. Okay. There are green line imposed over red lines, so we cannot see the green line. If you plot this, if you want to export this plot, you can click on this file and click on print tables. File, print tables to file, desktop, export, save. Okay. So for your function 1, the output, the time period. For your function 2, which is the joint displacement, for that one, the table, the in this column, it will display the displacements, and this is the time of that displacement. You can change this to your, you can send this to your Excel file and you can plot this. Okay, so this is regarding your time history analysis using unscaled ground motions. Now let us fastly move to your how to scale your ground motions, like how to scale your ground motions. Whenever I say you're scaling, the thing which you have to remember is that this is your epicenter of your earthquake. This point is your epicenter of your earthquake. Like at this point, the earthquake has occurred. There is a building over here. There is a building which is at a distance of Let us assume some 50 kilometers from this earthquake point, and then there is an other building over here. There is an other building over here, which is at around 100 kilometers. This one, 50 kilometers, and from here to here, it is 100 kilometers. 100 kilometers. And now let us suppose there is another building over here, which is at a distance of some, assume let us 500 kilometers. Okay, first building 50, second building 100, and third building 500. So whenever an earthquake wave travels from this point to 50 point, its intensity is higher at this point, right? The peak ground acceleration intensity is higher at this point, and whenever it is moving much further, its intensity will be decreasing when it reach 100 kilometers, and when it reach much further like 500 kilometers, its intensity will be more decreasing, like this one will be the higher intensity, the next higher, and the next higher. So whenever the distance between the earthquake focal point or the epicenter and the distance between these waves have to travel is more, the intensity will be decreased. But the thing which does it change is the wavelength or the frequency, like the frequency is nothing but the earthquake accelerogram which we have seen. It is called as the frequency. Those signature, like the frequency signature, cannot be changed. It will be the same frequency signature but with less intensity. I'll give you an example. This is the origin point of a sound source. Like ఇక్కడ ఒక పెళ్ళి అవుతుంది, ఇక్కడ ఒక పెళ్ళి అవుతుంది, అక్కడ కొన్ని సౌండ్ బాక్సెస్ పెట్టారు. ఇది ఒక బిల్డింగ్, లైక్ ఇట్ ఈస్ లైక్ సమ్ ఒక 2-3 బిల్డింగ్స్ తర్వాత ఉన్న బిల్డింగ్ ఇది అనుకోండి. ఆ తర్వాత ఇది ఒక 10 బిల్డింగ్లు ఉన్న తర్వాత ఉన్న బిల్డింగ్ అనుకోండి. ఆ తర్వాత ఇది ఒక 20 బిల్డింగ్లు ఉన్న తర్వాత ఉన్న బిల్డింగ్ అనుకోండి. అయితే ఈ సౌండ్ వేవ్స్ ఏవైతే ట్రావెల్ చేస్తాయో ఇవి ఇక్కడికి విత్ హై డెసిబెల్స్, అంటే ఎక్కువ ఇంటెన్సిటీతో ఇక్కడ వినిపిస్తాయి. ఆ తర్వాత ఈ పాయింట్కి వచ్చేసరికి అవి ఆ డెసిబెల్స్ అనేవి వినిపిస్తాయి, కానీ విత్ లెస్సర్ magnitude it will be heard over here this place. And if we go further, those sound waves will be we can hear them, but only with very less intensity, very less magnitude. Okay, so similarly with our earthquake ground motions, when the building is nearby it will be more intensity, and when a building is further will be less intensity, much further much lesser intensity, but the type of earthquake which all the three buildings experiencing is the same. Okay, got my point, right guys? You got my point, right? Okay, so what happens over here when we scale an earthquake ground motion, we'll be getting some peak ground motion PGA value over here, and we will be scaling like the earthquake happened over here, like the output is got over here. Whenever we're scaling peak ground acceleration, ఇక్కడ ఒక earthquake తీసుకుని ఇక్కడ వచ్చిన responses తీసుకుంటాం, ఆ తర్వాత ఇక్కడ వచ్చిన responses తీసుకుంటాం, ఇక్కడ వచ్చిన responses తీసుకుంటాం. But the original point where we mark where we take up the earthquake is somewhere over here. We don't know the intensity, so what we do is we scale it to 1, and we will be multiplying the intensity. We will be scaling it to 1 and we will be multiplying. I'll show you how to scale. At this point some intensity, at this point some intensity, at this point some intensity. So for that purpose we will be scaling the earthquake ground motions. Okay, now let us go for how to scale the earthquake ground motions. Where is the eraser? Okay, normal drawing. Okay. These are all your scale data. What exactly we will be doing is, we take one example of, I'll take the same budge at quick for showing you. Okay, guys. So this one is the time period. This A is the time period. This B is the original accelerogram which you have got. Original accelerogram which you have got. Then this one is the absolute values, like the absolute values of this accelerogram. This is nothing but ABS of B1. Like it will change the negative and negative into positive, and positive to, it will directly provide your positive values. What you have to do after this getting this positive values is, after getting all these positive values, you have to select the highest value, highest absolute value, like the maximum value, peak value. A peak value ekkadaithe untadante, somewhere at this one is the peak value. This one is the peak value. You have to select this peak value in this points, in this points. Then after that, what you have to do is, you have to divide the original accelerogram. You have to divide the original accelerogram with that peak value, with that peak value which you have obtained from this absolute values. So then what happens is that ఈ ఎర్త్విక్ గ్రౌండ్ మోషన్ ఏదైతే పీజీఏతో ఉందో, పీక్ గ్రౌండ్ యాక్సలరేషన్ తో ఉందో, ఇంటెన్సిటీతో ఉందో, అది ఇట్ విల్ బి స్కేల్డ్ టు 1g, 1.0g. It will be scaled to 1.0g. I'll be explaining, I'll be starting to do this once again. Like I'll be taking an original unscaled accelerogram, like Koina. Let us consider this Koina earthquake. Control Alt, Control C. You have to copy all these things. New. You have to click on Excel worksheet. You have to take an Excel worksheet. In this, scaling. Then you have to paste this over here. I will be pasting in the B column. Pages. Then what you have to do is, you have to click on equal to ABS. In this ABS, you have to select this B. Sorry, not B. You have to select this value and click enter. And then now you move this. This all the positive value will remain same. The negative value will become the positive. And you have to move this until the bottom. Okay. Until the bottom. Then what you have to do is, you have to get the maximum value in this column. Is equal to max of So the maximum value which is obtained in this column is 0.47378. Okay, now what you have to do with this value is, this is the first unscaled earthquake accelerogram, right? This one is the unscaled earthquake accelerogram. You have to divide this with this value. You have to divide all these values with this value. So now I'm again clicking on this equal to this divided with this value and click enter, and then you pull it down. For control Z, you have to divide this with the value actually with this 0.47378. Okay, okay, right. Okay. Uh, okay, here control S. Okay, so the main difference between this accelerogram and the accelerogram which we have created is, you will be understanding this when I plot this. This one is the unscaled, this one is the scale, this one is scaled to 1G, this one is scaled to 1G, and this one is scaled to this one is unscaled. Now if you plot a graph like okay, we haven't created the time scale. 1 minute. One is 0, enter, equal to 8 plus 4, right. Select data, this one is which axis, this one is the x-axis. In the x-axis we need the time period, and in the y-axis we need the unscaled accelerogram, and I'm creating another accelerogram scaled in this. This one is the time period, and this one will be our accelerogram, scaled accelerogram, which we have created. Okay. Okay. The blue lines which are overlapped by the red lines, the blue lines are your unscaled accelerogram, your first accelerogram. The red lines are your scaled accelerogram. The blue one, which are overlapped with your original one, are your unscaled, and this one, the lines which are scaled, these are your scaled accelerogram. The scale value of this is 1. Why? Because the maximum value divided by the maximum PGA is 1. So this one is the scale. The scale is 1 for this accelerogram. So after creating this type of accelerogram, what you have to do is you have to select this things which you have created. You have to select the scaled accelerogram and click on Control C. Control V. Okay. Control V. Okay. Control C. Control V. Okay, fine. Save, and then click close this, and then close this one. And also you can scale it to 0.9G, 0.1G, 0.2G, just by multiplying this with another value. Like now, if I want to scale this to 0.1G, which is equal to this into 0.1, enter, and again you can scale this. And again, if you want to scale this to some other values like 0.4G or 0.5G, which is equal to this one into 0.5G. Okay. So in this way, you can create different accelegrams with different intensities or peak ground accelerations. Okay. This one is how to create your accelegrams. The scaled accelegrams. Now let's go back to our SAP, and the way which you do this, you use this unscaled accelegrams is also similar to your original time history analysis. Like the only thing which changes over here is you can define functions, time history function, from file, add new function, Koina scaled, and then time is 0.02, browse, and in this select the Koina scaled. That is Koina scaled. Koina scale, open, and OK. Click OK. Click OK, and define load cases, add new load case in this Koina scale. This one is your time history, nonlinear, fast nonlinear analysis, acceleration in the U1, the Koina scale. You should not change the scale factor. We have previously used this formula called IG by R, right? In this scaling, in the scaled accelerogram, you should not change the scale factor. You should remain it to the value which it has been scaled to. Now previously we have taken the peak ground acceleration point value, and we have divided it with all the acceleration points. So it will be 1. If we multiply this to, if we multiply like how we did like 0.1 or 0.5, then you have to change this to this from 1 to 0.1 or 0.5. Now as we are using the 1 PGA ground motion, so the scale factor will be 1, and click on add. The scale factor has been created, and the number of output timeships will be 1001, 0.02, and click OK. Your third case has been also created. Click OK. Now in the analyze, set load cases to run. I'm not running this 2 load cases. I'm just running the Koina scale. Run now. So plot functions, Koina scale. So this one is the Koina scaled function output. Like whenever you scale the intensities of the ground motion, this will be changed. The peak ground acceleration will be changed, and depending on that, this is the output. Okay, click OK, and then click done. If you want to see the option like the displacements or the deformations, I'm going for deformations and the Koina scale for time period 15. I want the displacements. Apply. So this one is the change in your building. In this way, your building will be changed from the original position. It will be changed, deformed in this way while giving you a Koina a quick. And if you want to see the stresses, click on display, show force stresses, frame cables, tendons, Koina scale, maximum stresses, moments, apply. Again in the columns, as we are giving them in the x direction only, that's why we are not seeing the any moments in the y direction. If you give this Koina scaled accelerogram in the u2 or the u2, whenever you are defining this time history function, whenever you're giving in the u2 direction, this side or will be also the moments will be generated. So you have to check for two sides. As of now, we have only checked for the one side. You have to check for the two sides also. And then for the shears, shear in the 2-2, and the axial forces, torsion. If any torsion is developed, it will show over here. As our structure is moving in twisting, torsion is developed. For checking the torsion, you have to check over here. So that's it for this part. And click apply. If you want to show the values, click this option and apply, and all the values will be displayed on the structure itself, on the diagram itself. If you want a fill diagram, click on fill diagram and apply. Okay, so this is all about your time history function with scaled ground motions and with unscaled ground motions. I'll be explaining you once again the process. In order to develop a time history function, first what you have to do is you have to create a time history function. You have to select the from file and you have to create a new function. And then after creating a function, you have to click on define load cases. You have to create a new load case, which is telling you to the load case type as time history, and you have to click it as a nonlinear model. And you can also change this to direct integration, but I won't do this because it takes a lot of time. It takes a lot of time to catch the response of the building. But the more accuracy we will be getting in the direct integration method than the fast nonlinear method. And here you have to select the load pattern, load type as acceleration. The direction is u1. u1 is nothing but the x. Because we have used the u1 direction, we are not getting any moments or stresses in the other directions in the columns. If you use the u2, we will be getting the moments or stresses in the other direction. and this one is the function, the time history function, and this one is the scale. If it is for unscaled ground motions, the scaling should be like Ig by R. If it is a scaled ground motion, you have to put the value of the scale which you have scaled the unscaled ground motion. If it is a 1 PGA, you have to put it as 1. If you have scaled it to 0.1, you have to change it to 0.1 and click add. This one is the number of steps, like number of acceleration points, and this one will be your time step, like the interval between two accelegrams, 2 points in the accelegrams. For Burj it was 0.005, for Koina it is 0.2. This details will be given whenever you download any accelegram. In that accelegram, the details will be given regarding the number of output steps, number of the time period of each step, the location of the ground motion, the station at which the ground motion has been recorded, and the magnitude of the ground motion will be given in the, what do we say, accelegrams which we download. And then click OK. If you click OK, this will be saved. I'm not saving this now. And then directly you can go for the analysis, analyze, set load cases to run, and you can run all the load cases which you have created. Like in the pushover analysis, we have created the gravity load case, and first we have run the gravity load, first 4 load cases, and then in the second time we have run the pushover analysis. Unlike that, in this time history analysis, you can run all the load cases at once. And you can click on now I'm just changing the Koina scale I'm changing the direction. All these 3 are in the X direction. Now I'm just changing it to the Y direction. Click on define load cases, Koina scale, modify, show. In this I'm selecting the U2. Just remember guys, just the direction has to be changed, and click OK, and click OK. Analyze, set load cases to run. Not run all, run, and run now. Okay, if you see over here for the Corona scale, the deformations are also the forces are all, torsion is also developed in the other direction. If you click on display and this show deformed shape, the Koina scale, apply. See, now the deformations are in this direction, in the Y directions. In the display, you go for the force stress, moments, Koina scale, apply. The moments are generated very less for this Koina in the Y direction. If you go for the Burj or the Burj unscaled, these are generated in this direction. Why? Because we have given the direction we have given the earthquake in the X direction. Okay, so that's it about the time history analysis using the scaled and unscaled ground motions. Now I want you guys to clear your doubts. I'll be taking the ground doubts for the next 10 minutes, and then I'll be going for the live model. Okay, so now it's the time for your doubts and queries, guys. If you have any of your doubts and queries, just put it in the chat box or just unmute yourself and ask me. I'll be explaining. Hello.
Hi guys, do anyone have any doubts? So till now, I think it dealt with the time history analysis. So if you are clear with this, so by that Arun, you can start the modeling, right? Like
Yes, sir.
live exam.
Yes, sir. Live example.
Yeah. Please guys, so please respond because we are running short of time. Please, if you are very clear on this topic, then straight away Arun will start the next part. So by that we can close as early as possible. Okay, please. At least if you have no doubts, if it is clear, you can just text in box that you are fine. No doubts. Hello. Arun చెప్పండి. నేను ఇప్పుడే మాట్లాడాను అందుకే. Okay. No, I will mute now. Till now not muted. Now yeah, no, now it is. Yeah, guys, small information. Like so continuously for 2 hours we dealt with the today's session, and so what we do is we will have a 5 minutes break. So by that trainer also will he will get refresh. Okay, so by that we will start the modeling of the live project. Okay, so after your doubts clarification we'll have 5 minutes break. Okay.
So Vanaparthi Santosh Verma has a doubt where we use distance between epicenter to building in scaled analysis. So we use this scaled analysis for few types of analysis like incremental dynamic analysis and fragility analysis. There are few concepts like incremental dynamic analysis and fragility analysis. Just this is a large concept. This incremental dynamic analysis and fragility analysis is a large concept where we use this scaled ground motions. Like we will be starting from zero increments with 0.1 p ground axle, 0.1 g, 0.2 g, like that. I will be going up to 2g. Now we have done for 1g, like that we will be going up to 2g, and we will be checking at which point, at which ground acceleration the structure is failing. For that kind of analysis, and also for fragility of the structure, seismic vulnerability of a structure, we will be doing this time history analysis using the scaled ground motion. Okay, just go through this fragility analysis and incremental dynamic analysis one, and you will be understanding the concept of this scaled analysis. This will be very important. These concepts are very important if you are going to start your MTech project in this field, like the time history, ground motions, and earthquake engineering, earthquake ground motions. In this side, if you are going, the first thing is incremental dynamic analysis, and then fragility analysis. For these two types of analysis, we will be using this scaled ground motions. Okay.
Okay. Arun, what we do is we will have a break from so right now time is 12:52. So we will start again exactly by 1 o'clock. Is it fine?
Okay, sir. Shall it be at 1:05? Is it okay, sir?
Yeah, 1:05. No issue. Yeah, 1:05. Okay. So please, participants, you can also get refresh. Okay, we will start the session by 1:05. Okay.
Okay, you can stay inside within the chat also.
Okay, so I think the people who are supposed to go for namaz. So sorry guys, you can proceed with your namaz, and so I think the recorded video will be shared to your mails. You can proceed for the namaz. The rest of all you can stay back. Okay.
Okay.
So people, those who want to go for namaz, they can. Okay. So rest of all stay back and please be refreshed. Okay, get refreshed. Thank you.
There is a question from Sirisha. Without any reference records like Bhuj earthquake, how can we analyze or we should take highest peak records in that region? So whenever there is an earthquake, we'll be getting this earthquake records. Without the earthquake records, we cannot do this time history analysis. You can develop the synthetic records. You can develop the synthetic records by yourself. There will be a few steps to develop this synthetic records in a certain area. Like whenever you have to reach out this meteorological department and ask for the earthquake accelegrams for certain areas. Like earthquakes are occurring at each and every time, every day. A little bit of tremors or everything will occur, and that in that region, what are the tremors are occurring, you can ask for that earthquake accelegram, and you can use that for your time history analysis. Okay, is that clear, Sirisha?
Sirisha, you can respond.
Okay, she responded me privately, sir.
Okay, yeah, no issue, no issue. Yeah.
Okay. And any more questions? Okay, so I think I do not have any other queries or doubts. Okay, then I am leaving the chat now. After getting the refreshments, I'll be back. I'll be back at around 1:05 or 1:10, and then we'll start with the second section, like the live modeling. Until then, bye guys. I'll be returning soon. If you have any queries, just put it in the chat box, and I'll be checking them after returning.
Okay, guys, so please stay back. Okay, so you can get refresh and you can be online in 10 minutes. Okay.
Hello, guys.
Yeah, Arun.
Sir. Good
Yeah.
afternoon, sir.
Yeah, good afternoon. Yeah, I think participants are there. You can start the session.
Okay, sir.
Yeah, you
Okay,
can
then.
continue.
Welcome to the second section of the final day of your FTP on SAP-2000. In this session, we'll be learning regarding how to generate a model using your center line diagram, like how to do a live project, what are the loadings to be considered, and how to get the concrete design, and what are the different criteria should be followed while loading. Okay, let's start with the session. Initially,
Hello?
I'm just, yes. Hello.
You can continue. You can continue.
Yes. So initially for this, I am just opening a new file. Click on File, New Model. In this, select the blank template. I repeat once again, select the blank template in order to import a file from AutoCAD. Okay. Before going to import the file, I'll be just showing you the file which I'm going to import. Okay, guys, when you see this drawings, these are all the architectural and the structural working drawings. This is a G plus 3, which means a 4-story structure. This is the floor plan. Like in each floor, we'll be having 3 portions. The first portion, the second portion, and the third portion, with separate walls, separate walls. And then all the portions are similar. All the portions are east facing portions, and we have a small corridor in front, which is 4 feet 6 inches towards the side, where there is a lift in between this. On the right of the lift there are 2 portions, on the left of the lift there is 1 portion. sit out 14 feet by 10 feet, a kitchen 9.5 by 10, a wash area or utility area, attached washroom to the hall, and attached. This is a common bathroom, and this one is the attached washroom with the master bedroom, which is of 14 feet by 13 feet 5 inches. The children bedroom, and similarly all the other are also similar. This portion and all the three portions are similar. Now let us see the column placement. Let's see the ground floor plan. This is the ground floor plan. Like there are 1 2 3 4 5 6 7 8 8 bays in the x direction, and in the y direction 1 2 3 bays in the y direction. Okay, now this is the centerline drawing. This is the centerline drawing of your columns. Now from this, after designing, we have got few final sections. These are the structural drawings which we have got for the model, which is over here. Like a column C1 has 12 8 mm diameter bars, 12 8 mm diameter bars, and sorry, 12 18 mm diameters. It's not 8, 12 18 mm diameter bars as its longitudinal reinforcement or the main reinforcement, and then 8 mm bars at the distance of 150 mm center to center as are provided as ties, and this is the hook which should be in 135 degrees towards the inside. And this one is the beam drawings, and these are the beam layouts. Okay, this is a live project which we have completed. In this, I'm going to do is I'm going to save this project as a new place. Save this drawing as DW file at on the desktop. Then what I'm going to do is the desktop where I have saved, I'm just copying this for Control C, Control. Have to create a copy of that file which I want to import it into the SAP 2000. So I have created a copy, and then I'm just clicking on this option and click on this open the copied file. Open. In this file, what I have to do is I have to get the centerline diagram. I have to get the centerline diagram. For that, I'm deleting everything else. From the previous drawings, we have got the centerline drawing. Okay, like this is nothing but this is the centerline drawing. The same drawing I have copied from here, and then I have pasted it at this place. Okay, and then I'm just deleting all the other drawings. I'm deleting all the other drawings. I'm just selecting this drawing, which is the centerline drawing, and I'm just moving it to the center, moving it to the origin. Okay, I just moved the centerline diagram to the origin. Then what I have to do is I have to rename this AutoCAD drawing. Import, save, and then I'm just closing this drawing. Okay. After that, you have to go back to your SAP 2000, and in the file you'll be having this option to import the drawing. Import. In this import, you can import the AutoCAD DXF file or the AutoCAD file which we have just created. We have to give the directions in which this AutoCAD file has been imported. Okay, this drawing is not imported properly. I'm just importing it once again. I have to change this to DXF file. Have to change the AutoCAD DWG file to DXF file. For that, we have to just open this one. In the other options, you have to go for DXF file, AutoCAD 2013 DXF file, and save this file. Once it is saved, you can close your AutoCAD. This is the DXF file. Where is the DXF file? Okay, DXF file. Right. Here's tab file, import AutoCAD DXF file, import, open, and again you have to change the direction. In AutoCAD, the global direction was Z was up. In this, Z is all the same. Z is up. Click OK. Okay, you have to close the AutoCAD before importing. Where 0? Definition is 0.
Hey Arun, any problem in importing?
Yes, sir. The file is not importing. I'm just trying to import. We have also another option to do, but it is manually. If we import, we'll be getting the direct lengths.
Okay.
Okay, then.
క్యాటరింగ్ ఉన్నారు ప్రవీణ్ సార్ క్యాటరింగ్
క్యాట్రిడ్జా ఎందుకు మొన్న 4 తెచ్చిచ్చారు కదా
కానీ ఇప్పుడు ప్రవీణ్ సార్
So your mic is turned on, sir.
మీ దగ్గర ఒకటి తీసుకెళ్ళి
Okay, so the file is not importing, guys. There is a small error over here. What I will do is I'll just explode this. Actually, the file should be imported like DXF file should be imported, and the current there will be the grid lines will be formed over here, but it is not importing. So what I'm doing is I'm just giving it the dimensions. So it is in 14 feet 6 inch. Now I'm just changing it to note this values, guys. 4581 mm. Just take a paper and just draw this grid lines like 1 2 3 4 5 6 7 8 9 9 grid lines are over here. 9 grid lines. 9 grid lines. The first one is 4581. Okay, we haven't, this one is not up to here. Snap on. So it is 4419. The first bay distance is 4419. The second one distance is 4495. 4495 is the unit is mm. 4495. And the third one is 3810. Just note them down, guys, once. 4419 again. 4495. 111447. If whenever your AutoCAD file doesn't import, this type of things we have to do. Like we have to calculate the distance manually, and we have to enter them. 4419. 4495. And this one is in the x-axis, and the next one in the y-axis. So select the distances between these three. 3987. 7. 4720. 24. So 4724. And then 3022. And finally 1600 for the corridor. 1600. Right. Now let us get, after noting all this down, let us get back to our SAP 2000, and let's open a new project, new model. In this, we have to go back to our 3D frames again. In this 3D frames, you have to go to the use custom grid spacing and locate origin. On this edit grid, and this again we have to change this to spacing. Change this to spacing. And the first A grid. What is the length of the A grid, guys? Just put them in the chat box. Length of A grid. Have you noted down the dimensions before, the grid dimensions? .4419. Okay. So 4419 is 4.419. Right? Okay. The next one. Next one. 4.495. The next 3.180. The next 4.419. This one is 4.4189. 4.419 at E. 4.495 at F. 1.447 at G. 4.419 and at H. 4.495 and click on add. And the last one should be remain to 0. Okay, guys, we have entered all the grid data in X direction. Now let's go to the Y direction. The Y direction, what is the first spacing? 3.987. The second one, second one, 4.724, and the third one, 3.022, and then the last one, 1.60, and we have to enter one more grid line, 1.6, sorry, 1.600. Okay, so these grids, if you see over here, these grids are formed in the opposite direction, and I want this part to be on the bottom. So what we have to change is this one should be 3.987. Sorry, we have to enter this values in the order which are from bottom to the top. Again, this one will be 0, this one will be 1.60, this one will be your 3.022, this one will be your 4.729, and this one will be your 3.987, and you need one more over here on add. This one will be your 3.987. Okay, you can delete this one, right? So these are your grid lines in the y direction. As our building is G+3 building, which means we are having 4 stories, the base story and the 3 stories above, we can add few more over here, and this one will be your 3 meters, and this one will be your Z3, Z4, and then so that's it. We have completed. If there is no importing, we have to do them. We have to calculate the length of the direction manually, and then we have to enter them in the grid IDs, grid spacing, and click OK, and again click OK. Okay, your building will be completely created. And now what you have to do is you have to delete everything, and you will be left with your grid lines. You are left with your grid lines. Now let's see what are the properties which we have given. Note down the column dimensions there. The column dimensions, all the columns are of the same size. It is 230 cross 460, 230 mm by 460 mm, and for the beams it is 230 by 370. Okay, I repeat this once again. For your columns, the dimension is 230 by 460. For your beams, it is 230 mm by 370. Okay. 230 by 460, 230 by 370. Okay. Now let's get back to our SAP-2000. Now let us define few materials. For this building, I'm using M30 grade of concrete, and I'm using FE500 grade of steel. Add new material. In this, I'll get India concrete and M30. Okay. Add new material. India. In this concrete, I have to select the rebar for the reinforcements, and then FE500 I am using. HYSTD grade 500. Click OK. we have created 2 grids, and I'll be creating one other grid for the beams and the slabs. This rebar, concrete again India, and M25, click OK, and then again click OK. Now click on the define section properties, frame sections, and in this add new property, and this select the concrete, select the rectangle. I'm just giving a section C1, and what are the dimensions of the column which we have taken? Guys, I want you to respond in the chat box. What are the dimensions of the column which we have taken? 230 by 460, right? So 0.46 by 0.23. Okay. The material for our column is M30, and then the concrete reinforcement. I'm using 500 bars for both the longitudinal bars and the confinement bars, and click OK, and again click OK. And I'm creating a new property, or else I'm copying this property. This one will be your B1, and then what is the depth of your beam? Beam 230 by 370, right? 0.37 by 0.23. Okay, and this one will be a M25 grade of concrete, and the concrete reinforcement you have to change from column to beam, and click OK, and again click OK, click OK over here too, and then go back to your plan view and draw the beams first. Using this quick draw frame cable, select this option and select the beam B1. As all the beams are of the same property, you can drag this along and create all the beams. Now if you see in our drawing, the AutoCAD drawing, this is the beam layout. We do not have any beams over here. We do not have any beams at this grid point and at this grid point. So what I'm going to do is, I'm going to delete this beam. Okay, and again I'm going to the bottom story, and I am clicking on this draw frame cables B1, and again I'm drawing this again, and I am deleting these 2 beams, and I am going to the next bottom story, and I am clicking on this option again, and the B1, and drawing this beam, and then selecting this and delete. And at the bottom, I'm going to the bottom, but there are no beams over here. Now what I have to do is I have to give the columns. For that, what I'm doing is I'm going to the exit view, and then I have to draw them manually, or to draw frame cable. In this, I'm just selecting the C1, okay. I have to select them manually. This one is in the which frame? This one is in the this frame we have completed. This frame we shouldn't draw, and this frame we should draw. You can either give the frames like this, or else whenever the program is turned on, like whenever your working screen has opened, all the grid lines will be displaying the beams and columns. You can select the lines parallel to X or lines parallel to Y, and you can assign this property. Or else if there are multiple properties of your beams and columns, like different types of beams and columns, you have to do like how I am going to do now, like selecting them individually and giving them. Okay, this is the final frame. Now your modeling of your frames and beams has been completed. Now what you have to model is you have to model your slabs. So further, click on define section properties, and then in the area section, create a new material and new section. This one will be your slab section, slab 1, and this you have to select the thickness as 0.150, 0.150, and the base material should be your M25, and the type should be shell thin. For each type of slab material, there will be different types of analysis. Some like shell thin and shell thin. The difference between these two is shell thin can be used for your slabs, which are having very less, what we say, thicknesses, or in the shell thick, can be used for larger thicknesses such as domes, and plate thin and plate thick can be used for your claddings. Like whenever you're doing wind analysis for those claddings, you can use this plate thin and plate thick. A membrane is nothing but a slab or any solid, any plate having n number of surfaces, n number of layers. Like if you want to provide 3-4 layers in a slab, you can use this membrane, and same goes with the shell. Now I'm just clicking OK. Slab 1, click OK. Now I am going to my XY, like the plan view, and this one is at the bottom. Now in the bottom, I have to assign this hinges, sorry, restraints. I'm going to select this. I'm clicking on assign, joint, restraint, and this, the fixed restraints, and apply. Click OK, and then I'm going to the first floor, and then I'm selecting this option called as quick draw area. Quick draw area. I'm selecting the slab one. I'm just dragging it over all the grid lines. Now the slab is formed at these places also. Like I do not need my slab over here. Like this is open to sky. This part is open to sky, and this part we are providing the staircases, and this part, this part, and this part, and this part, I do not require my slab. After completing, I'll be deleting this slab. I'm just going to the level 6, and again I'm dragging it. So I'm going to the top level, and again I'm dragging this. Okay, now after creating, I have to go to the select option. You have to select the slab, delete those slabs and go to the next immediate level. And then again, you have to click on the delete option, delete the slabs, and go to the bottom layer. Fix, and again, delete the slab. Now your modeling has been completed. You can change this view to the 3D view, and you can click on this set display options, and you can go to the general, and you can click on this extrude in order to see the extruded view. Okay. As we have planned, this is a G+3 structure. I just only have created the G+2. While modeling in the first, like whenever you are doing this view, sorry, edit grid data, modify show grid data. In this, you can add one more layer. Okay, we have to create one more Z grid line. This is Z3, Z3, Z4. Add a grid line, and this one will be a Z5. And click OK. Okay. Okay. So you have to create a layer over here also. For that, I'm going again to my exit to the Z9 level, and just moving this to offset or standard view. Apply. Okay. Level at the level 12. We have to create this frames. First, we have to give the beams, and then draw the beams. And again, in this, I do not require my beam over here. I'm deleting this one, and I do not require my beam over here. I'm deleting this one. And the next one, what you have to do is go to slabs and create the slabs over here. And in this also, I do not require my slabs over here, over here, and over here, and delete the slabs. Okay, now what I have left with is I have to create the columns also. For that, I'm going to the exit, column B, C1. Okay, this one is the outer layer. We do not need any columns over there. So that's it. We have completed our modeling completely. Then the next part which we have to do is we have to go for the analysis, like the type of loadings which we do. If it is a G plus 5 structure, like more than 5-story structure, the wind analysis and the earthquake analysis are necessary. So as this is a G plus 3 structure, we are going for only for the gravity loads. In this, the first gravity load which you have to consider are the dead loads of the walls. So generally all the outer walls, the dead load will be 12.5 kilonewtons. 12.5 kilonewtons. The inner walls which are having a thickness of 6 inches, the dead load will be 9, and for the inner walls which are having a thickness of 4.5 inches, the dead load will be 6 kilonewtons per meter. I repeat this once again. For outer walls which are having a 12-inch thickness, for outer walls which are having a 9-inch thickness, the load or the UDL which has to be applied on the beams is 12.5 kilonewtons. For the inner walls which are having a thickness of 6 inches, the load to be applied on the beam is 9 kilonewtons. And for the inner walls which are having a thickness of 4.5 inches, we have to apply a load of 6 kilonewtons. And for the parapet walls, like the compound walls and the parapet walls or the railing walls on the top of your building, you will be having the parapet walls, right? For those walls, you have to measure the thickness and the height. For a general floor, we'll be having the height of 10 feet. For those type of walls, we'll be having the height of 3 feet or 3.5 feet. So we have to measure. In general, we'll be providing a UDL of 2 to 3 kilonewtons for those type of walls. For the parapet walls, we will be providing 2 to 3 kilonewtons UDL. So now let us start with the dead loadings. Now I am selecting, going to the 3D view, and now I'm selecting all the properties, frame section, and the B1 section, select. Okay, close. Now what I am doing is I am just providing the internal wall thickness, like I'm providing 6-inch wall, like I'm providing 9 kilonewtons load, 9 kilonewtons load on every beam. First I will provide 9 kilonewtons load on every beam. Assign frame loads, distributed loads. In this, 9 kilonewtons for every beam, either it may be an internal wall or external wall. I'm providing 9 kilonewtons of load and clicking on add, apply. I'm applying the load, apply. Okay, so now if you see, all the beams in the structure are applied with 9 kilonewtons of load. Now next what I am doing is I'm only selecting the external loads, like I'm selecting the external walls, which are external walls are nothing but my external periphery walls. Which are having a wall thickness of 9 inches. All the internal walls are having a thickness of what do we say, 6.5. All the external walls are having 9-inch thicknesses. I'm selecting all the external walls. Guys, what is 12.5 minus 9?
3.5.
1.5. So we have to add an extra 3.5 load over this external walls in order to change from 9 kilonewtons to 12.5 kilonewtons, right? Select all the walls, all the external walls. So we have selected all the external walls. So I think we haven't selected. There is one more. This level.
Yeah, Arun, I am back, Arun.
Okay, sir. Okay, sir. So we have selected all the external walls. Now we have to click on assign, frame loads, distributed. In the dead load, add to existing loads. We have to add an load of 3.5 kilonewtons. 3.5 kilonewtons, so that it will be changed from 9 kilonewtons to 12.5 kilonewtons, right? Click on apply. Okay. Now if you see over here, the internal beams are with 9 kilonewtons load and the external beams are with 12.5 kilonewtons loads. So whenever you see this, guys, this is the roof. The top part is roof. So we do not have any walls on the roof. So for that, what we have to do is you have to select all the roof beams. You have to select all the roof beams. You have to select all the roof beams and click on assign, frame loads, and then distributed. In this direct load, delete existing loads and click apply. Now the roof beam loads will be completely deleted, and then what you have to select is you have to go back to the roof, the top level. The top level is at 12. You have to select the exterior roof walls, like where the parapet wall is running or the compound wall is running. And over here, I'm selecting this one. Okay, you have selected all the external walls of your parapet or the roof, and you have to assign a frame load of let's consider 2 kilonewtons for the 3 feet compound wall, 3 feet parapet wall. Let us consider 2 kilonewtons. Click on apply. Now, so all the loadings for the walls has been completed. And one more thing which you have to remember is that there are no walls on the balconies or the corridors. Like at this place, there are no walls. So what you have to do is you have to select this place, all these beams, and change its loading, assign frame loads, and then distributed. You have to replace its loads with lesser loads like 1 kilonewton. Apply. Okay. So your what do we say? Loadings for the walls has been, dead loads for the walls has been completed. Now the next part of your loadings will be your loadings on the slabs for the live loads and the dead loads. Dead loads generally we are giving for the slabs is 1.5 or 1 kilonewton for the floor finish. So for that, go to select, the select, go for properties. In this, I'm going for the area section, slab 1, select. All your slabs are selected, and in this assign, I'm going to area loads, uniform load. In this dead load, I am giving it as 1 kilonewton, which is considered as our floor finish. Generally it will be 1.5. Now I'm just giving it as 1 kilonewtons, and add to existing load, click apply. Okay, all your floor loads will be given 1 kilonewton per meter square as the floor finish. Now let us go for the live loads or for a residential building. For this, what you have to do is the live loads part will be in the ISC 875 part 2. In this ISC 875 part 2, live loads or the imposed loads. In the page 7, if you see over here, for residential buildings, all rooms and kitchens, the floor load or the live load should be 2 kilonewtons per meter square. For corridor, passages, staircases, including fire escapes and the storerooms, it should be 3 kilonewtons. So we should remember these two things: 2 kilonewtons and 3 kilonewtons. And for toilets and bathrooms, it should be 2 kilonewtons. So I'm just considering this 2 kilonewtons for all the slabs which are inside the building, and 3 kilonewtons for our corridor slab. Okay. Now I'm going back to my SAP again. I'm going back to my SAP, and then first let me give this, select this slab properties, area section, and then slab, select, close. On the assign, in the assign, I'm going to area loads and uniform shell load. I'm giving, so there is no live load we have created. Okay, fine. Assign area load, uniform shell. In this live load, let us give a 3 kilonewtons first, and then we will be selecting all the slabs and changing the load on that slab, replacing the load. 3 kilonewtons at the existing load, apply. Okay, now let us go to the side view. In the side view, let us put this in the side view, and just select all the slabs over here and click on assign. In this assign, go to your area loads, uniform shell. In this, from 3 kilonewtons, change it to 2 kilonewtons and replace the existing loads, apply. Okay, now if you go back to your XY plane, XY plane, if you see all the slabs inside they are 3 kilonewtons. I think we have applied in the wrong way, right? All the rooms should be 2 kilonewtons and the passages should be 3 kilonewtons. We have applied it on the other side, like, okay, the 3D, select properties, area section, slab sections, select, close, assign, area loads, Inform shell 2 kilonewtons. If replace existing loads, apply. Okay, and then again this part assign AR loads uniform. In this I am going to assign 3. Replace existing system load, apply. Okay, and then go back to your XY. These are 2 kilonewtons inside the living room, hall, toilets, washrooms, bedrooms, or the loads are minus 2 kilonewtons per meter square, and for your corridors it is minus 3 kilonewtons. Okay, now your loadings has been completed. The next thing which you have to do is you have to create load combinations. In order to create load combinations, click on define, and this click on load combinations, add new, or you can click on add default design combos. You have to select for, if you want to add manually, add new combo, and then strength parameter and deflection parameter. For that you can add strength and dead load, add 1, and live load 1. This is the one load case, or else you can create dead load 1.5, add, and again live 1.5, add. In this way you can create the strength and deflection parameters, and you can create your own type of load combinations from the ISC 1893. In this ISC 1893 you will be getting all this parameters for the strength and deflection checks. I'm just going to use the default design combos. Click on add default design combos. In this we are giving the combinations for concrete frame design. Click OK. 2 combinations are created. As we are having only dead and live load, 2 combinations are created. If we are having the lateral loads such as earthquake loads and the wind loads, more combinations will be created, like around 21 or more than 23 combinations will be 23 combinations, and sometimes 29 combinations if you have response spectrum or time history or pushover. Depending on the load types, more combinations will be created. For now I'm using this 2 different type. This one is 1.4 of the dead, and this one is 1.2 of the dead and 1.6 of the live load, and click OK. Now your modeling has been completed, your loading has been completed, and your load combinations will be have been completed. After that you have to click on analyze, set load cases to run, and run now. And in this, after your analysis, for going to the concrete design, you have to click on this design, concrete frame design. Before starting the concrete frame design, there are few parameters which you have to check. Those are view revise preferences. You have to select the code book over here. Now it is ACI, American Concrete code book. Like in this, you have to change it to IS 456-2000, and all the parameters will be changed according to the code book. And then click OK. And then you have to click on design, concrete frame design. In the select design combinations, already all the combinations which you have created for the strength parameter over here before the analysis will be saved over here, and click OK. If you want to give few more parameters, you can also define them over here. Click on the design, concrete frame design, and then start design check of the structure. Okay. Whenever you see this color, the ratio should not be exceeding more than 1. The ratio should not be existing more than 1. So if you check any of the Now what you have to do is, it is a little bit messy over here. You have to change this from meters to mms. Okay, when you change from meters to mms, it will display all the reinforcement AST ratios. Like I'll be putting them in the XZ view. It will be much clearer. Okay, when you see over here, this is 846 mm square is the AST obtained for this column. If you go down, it will be increasing 846. It is 846 over here. If you see over here at the bottom, the AST will be more. If you go up, the AST will be decreasing, as the bottom columns experience more axial load than the top columns. In some cases, the top columns will be experiencing more moments due to the lateral loads such as wind loads and earthquake loads. More at such scenarios, the top columns will be also experiencing more AST, will be generating more AST. You have to note down all this ASTs for each columns, and then you have to do the detailing manually in your AutoCAD. Like you will be getting the, what do we say, the AST value. You have to set a, what do we say, set a dimension or a diameter of the rebar, and depending on the number of rebars, you have to arrange it accordingly in your rectangular section. Either it may be your column or your beam, you have to arrange it accordingly. When coming to the beams, uh, the beams reinforcement or the beams AST will be displayed like this. These are the bottom bars. This one is the top bars. The top bar here is more, and then when it reaches a certain length, it will crank down. There will be a crank, and it will be cranked down, and then the top bar reinforcement will be decreased over here. This will be only the supporting bar reinforcement AST, and it will be cranked down, and it will be increasing at the bottom. Okay. And after this, if you want to check whether all the structure has been passed or not, or any structure any element is overstressed, you have to go to design, concrete frame design. In this, verify all members passed, and it will display all concrete frames passed the stress capacity check or are designed. So if you get any section failed over here, sorry for the delay, all concrete frames pass the stress or capacity check. If any of the concrete frames are not passed, you have to select those concrete frames will be displayed over here. You have to select those frames, and you have to either increase the what do we say, the grade of steel or grade of concrete, or either you have to increase the cross-sectional dimensions of that section so that it will pass. And after that, if you want to export all this data, you have to click on design, concrete frame design, and display design info. This is the design info. If you want to export this data, you'll be having an option called in the display. Click on show tables. From this, you will be having the concrete frame, concrete summary, In this, you have to select these two options and then click OK. I repeat this once again, where you will be getting all these tables. In the display, in the show tables, in the concrete frame, concrete summary data, first one and the second one, click OK. You will be getting all the data of your column. For column 1, the location at 0, at 1500 and at 300, the area, AST area, for which combination the AST area is over here. This one is for the shear reinforcement. Okay, so if there are any warnings or any failures, it will be displayed over here. You have to select this, you have to send this file to the Excel, export this to Excel, and you have to draw each column manually in your AutoCAD, and you have to detail them. The designing part will be completed in the software itself, and from the outputs of the designing part, you have to what do we say, draw the element detailing. You have to draw the detailing, like the structural detailing, the rebar area, or anything like this. You have to do this type of structural detailing depending on the AST which you have got. Okay, so this is all about your real-time model, and few other things which you have to remember in this. Your real-time modeling is you have to follow all the codes for providing the live loads. Now I have forgotten one more thing. On the floor, on the roof, all the slabs should be given 3 kilonewtons of live load. 3 kilonewtons of live load, because this areas are not for kitchens or what do we say, bedrooms or halls. So as per the code, corridor, passages, staircases, it is 3. There will be one more option for one more thing in this code for roofs, balconies, and roofs. Okay. So rooms, indoor, balconies. Okay. So the roofings will be coming under the balconies only. Why? Because they are not not any area where do we live. So all the roofs will be should be provided with 3 kilonewtons per meter square of live load. Okay. So this is all about your project, guys. You have to check the AST which has formed in the project, and you have to do the detailing. Okay. So I think that's it for today's section. I think that's it for this FDP. I'm just handing over the FDP session to VAMSI KRISHNA sir. Sir, are you available? Hello. Yes, I hope you have understood how to do a real model. And also in this model, you have to provide the staircases loading and also the water tank loading. Just you have to provide one more floor above, and just you have to draw beams and columns, and you have to impose the load over it, and you have to calculate them manually, and you have to impose them. Until now, if you have any doubts regarding this part, like the live load, live modeling and analysis and design part, you can go forward and ask me in the chat box, or you can unmute yourself and you can ask me. You can put your questions or doubts or queries in the chat box, or else you can unmute yourself and you can ask me.
I hope all participants had a very good experience towards creating a model and how to import the things from AutoCAD to StatPro, isn't it? Right? Yeah. Sorry, AutoCAD to SAP-2000. Yeah. I think they can start doing, for a small residential building. So by that they will come to know how to do the kind of analysis of all the things. Yeah. Right. Any doubts, guys? So if there is no any doubt, so by that we will end up the session, and we will give vote of thanks to Arun for conducting this 5 days workshop very effectively. Right. So guys, any doubts? So you can put it in chat box, or you can unmute yourself and you can ask, or you can put question over here. That's it. No doubts. Guys, you can respond. If no doubts, we will go with the vote of thanks. Okay, Arun. So I think they can, they can ask doubts even in our WhatsApp group. So I think you can answer to them whenever, whenever it's flexible. Okay, right. So yeah. So thank you so much for all the participants for present. I mean, for attending this 5 days faculty development program on SAP 2000. First of all, I would like to thank our management, C.H. Mallareddy Garu and Dr. Ramaswamy Reddy Garu, Director of Mallareddy Engineering College, and Dr. A. Ravindra Garu, Principal of Mallareddy Engineering College. I would like to thank all of them for giving this opportunity to conduct this faculty development program more effectively. And I thank our head of the department, Dr. J. Selvin Babu Garu, for supporting me in organizing this FDP very successfully, and my co-coordinator, Mr. E. Rakesh Reddy, who supported me in in all aspects of organizing this FDP. And I would like to thank our main resource persons. Without them, there is no way to conduct this program. So because they are very busy with their design works, but still it was happened just because of their cooperation. And I thank Arun and Tejashwini for for believing in me and spending time in this FDP. I think all the participants had very good experience in this 5-day workshop, 5-day FDP. So why? Because we organized this software program to make every PG research scholar to do or to pursue their MTech thesis in that direction. Okay, because this is the latest software, so where you can't get trainers on this software particularly, and there is a misperception that there are a lot of videos there on SAP 2000 in YouTube. No guys, you can't find these effective videos in YouTube also. Okay, so in that way we try to organize these kind of software training programs related to all latest civil design related things. So not only this, even we are going to plan latest softwares like SketchUp, Okay, because nowadays it's very important in architectural point of view. So yeah, so that's what. And one more thing, just in this short gap, actually I posted 5th day feedback. So I request all of you, so please fill that feedback and please give your valuable suggestions. And end of the day, I'm going to share you overall feedback also. Okay, so please, I request each and every participant. So there are around 60 participants. I don't know others why they didn't attended for today's session, because each session is very, very important. Anyway, you can just go through all these recorded videos in the link given in your mails. Yeah, so I'm gonna share you overall feedback link also, so to your mail. So please try to fill that feedback. Based on that reply, I'm going to share your certificates to your respective mails. Okay, so please inform your faculty friends, MTech students, all of you, like, please inform them. Without overall feedback form, we can't generate certificate. Okay, so once I receive feedback from all the participants, so then we can generate the certificates and we can share to your mails immediately. Okay, so please inform to your friends also, because that is very, very important, because your feedback counts to make next programs a success. Okay, so that ends with FDP, which is one week FDP program. Yeah, so that's it from my end. I thank everyone once again for spending your time in this FDP program. Right, Arun, do you want to share anything? You can.
Personally, I thank VAMSI KRISHNA sir for giving us URCAP planners and designers this opportunity to take up the FDP. It was a very good journey from the very first day. Even the students or the participants were very active, and it was a very good journey throughout the 5 days. And I thank the HOD sir and all the organizing team, and especially the VAMSI KRISHNA sir for asking me to do this, taking up this FDP program. And I thank my colleague Tejashwini, who has taken the FDP for the 2 days. And thank you very much, sir. It was a great opportunity for taking the FDP at your college, one of the most reputed college. Thank you for giving me this opportunity. So we'll be looking forward to do this type of FDPs more and more.
Definitely.
Thank you very much.
Because it's all based on students' feedback. Whatever the software they feel that it is very important to their career, definitely we are ready to do that. We will find out the resource persons for them for the right way. Okay, and one more thing, last point, the WhatsApp group which was created on this FDP to SAP 2020, it will be active. Okay, we are not going to close that group. Okay, so that group will be active. You can put all your queries in that. So whenever trainer and ourselves are free, definitely we will try to respond to your questions. Okay, right, thank you so much, and thank you all.
Hello.
Yeah, closing.
If there are any doubts or queries, I'll be available for the next 5 minutes. So I'm open for you guys.
Yeah, fine, Arun. Actually, we are closing the session. Okay. Yeah. So
okay,
they can put their queries in a group. Okay.
Okay, sir.
Okay. Right. Thank you. Thanks.